Hello and welcome to another video by the Holiday Computer Club. Today I got asked about some Java and Spring Boot. So what I'm going to do is I'm going to make a little sort of intro video where we're going to start making some sort of a Spring Boot API. This may span over multiple videos. We'll see how it goes. So I'm going to jump straight into sharing screen and we'll talk about a few of the concepts of what we're doing. Right, so we've got this Spring Boot starter intro template that I've made. It's just literally a bare bones Spring Boot with no controllers, with no entities, with no repositories or services or anything in it. It's just literally what you would get if you went straight to like Spring Initializer, made a new project and set the right settings up to be ready to make an API. It's not even got a README at the moment, but we can deal with that. So if you've got a GitHub account, feel free to use this template. So you click on use this template and it'll ask you where you want to put it and so on and so forth. If you don't already have a GitHub account, we can make videos on how to do that. There's plenty already on the web. Feel free to go back, do that, and then come back to this video when you've done that. I'm going to say use this template and create a new repository based on it. We're going to use the Holiday Computer Club. We'll make a starter Spring API, maybe service. So we're gonna just concentrate on creating services at first. So we'll do that. So we're not really working with a database as such directly. We're going to be creating services that do a business logic thing. We'll talk about the concept of the differences between the different things as we go. But for now, I'm just going to make a new public repository. Calculations. Let's just make a calculator. We'll make like a calculation API or something. And all this is going to do is literally probably do basic rudimentary mathematics. So we'll send it some data and then in the post, and then it will return to us some data back with the result to whatever we asked it to calculate. So let's create this template. Oh, sorry, create a repository based on the template. Generating the repository. Once it's generated, I'm going to head over to my terminal, go into my web folder, my projects. And then what I'm going to do is I'm going to click on this code icon here and literally copy the actual repo. Then I'm going to actually do a git clone, and paste that repo in. Again, if you don't know how to use Git, feel free to jump into a sort of Git basics video. But for now, let's just move forward. So we've got this starter Spring API service. So let's go in there. Have a quick look. We've got a Gradle W, Gradle source, settings, Gradle bat, build Gradle, and so on. This is just a simple basic project. So I can open this in something like IntelliJ. So let's do that. Open. And then I'm going to go to my documents, projects, Java, BD, web, starter Spring API. There we go. Click open. Yes, I'm going to trust this project. So I'm just literally made from scratch kind of thing pretty much. So it should be fine. Now we're going to have it start the Gradle daemon and do its thing and start sort of building out everything for me. And we'll come back once it's built. Okay, after that, we should have this saying build successful in X amount of seconds. This was 39 seconds. So I thought I'd pause the video while waiting for that 39 seconds instead of having you just stare at the screen for 39 seconds. So now that we've got that built, we need to now dive into the project. So we go into source, main, Java, and see this web API application. So if I double click this and click play and run web application main. If your tooling is correctly set up, this will instantiate a instance of the Spring Boot application, run it, and we'll have some feedback down here. So once it's actually running, you'll see all of this sort of, you've got the Spring sort of banner here with the version of Spring Boot, along with some other stuff. And now right at the end, what you're waiting for is started the actual application. If we scroll over a little bit, we'll see that it's on port 8080. Now, we have an actual Spring server running. It's there, it's doing its thing. Now, we do not have any endpoints. So if I go to localhost port 8080 and try and look at anything, it's going to tell me I've got an error. It can't find it. There's nothing there. It's not found anything because we haven't made any endpoints. We haven't made anything to actually serve on this. So the construct and the server itself is there, but the content is not. We've got to make that. That being said, let's stop the server. Minimize that out of the way. And let's start building out what we need. So for an API, there's a few things that we'll say required, but you can build it out however you like. I'm going to build it out in a sort of what's logical to me. I'm going to start based upon the entity, build out some sort of either repository or service, and then a controller to interact with that repository or service that then interacts with the entity. So what I'm going to do is I'm going to make some packages. I'm going to make an entities package. I'm going to make a repository package. Probably repositories might have been a better naming convention for that. I'll actually delete that for a second. Rename that to repositories, plural. Repositories package. Then we'll have a, what else do we need? We'll have a services package. Probably a config package in case we ever want to configure anything. We're not going to be using all these packages yet, but the first package we want to deal with is the entities. I'm going to make a calculation entity. So let's make a new Java class called calculation. Okay. And for the calculation, I'm going to want a couple of things. I think I'm just going to keep it simple and we'll have two operands and a result. So some input data of possible two items and a result to make it a simple calculation. We can always build on this and make subclasses of it and build out other entities, but for now, we'll do this. So for the actual entity that I'm going to build, we're going to want to kind of have some sort of information in there. So I want to make some sort of data, for instance, like fields in the data. So for this, I'm just going to work with integers for now. And I'm going to say op A, and then an integer op B, and an integer result. So operand A, operand B, and result. We could have operand A, operand B, and operator if we wanted to. But for now, I'll just do it this way. It's up to you. You can add your own sort of bits and pieces to this as we go. But for now, I'm keeping it as simple as I can think of. Now, we have a development package called Lombok, which means we can get away with having to do too much boilerplate stuff ourselves. We can use what we call annotations. We can do at stuff to make it do things. What I want to do is I want an all args constructor. So that's the same as me writing out a constructor that uses all arguments. I also want a no args constructor. And then what I want is I want some interface called data. So at data. This incidentally would create a required args constructor as well, funny enough. But that's fine. We're just putting these constructors in just so we've got them. So now we've got this data here, these three fields. We've got this calculation class. So we're creating this whole construct here as an entity. Save that. And I'll call that a day for the entity. That'll do for the moment. We can add stuff to this as we go. For now, that'll do. Now what I want to do is I'm not going to bother with repositories just yet. I'm going to build out a service to act upon this entity. So I'm going to make a new class called calculation service. Okay, and this one's going to be an actual service. Okay, this is where we do business logic, whether it's mathematical logic, whether it's something to do with anything that's non-specific to databases as such. You can actually still call database stuff, but usually you would do that through a repository. So the service would communicate with the repository would communicate with whatever database driver would communicate with the actual database, but we're not going to really bother too much about that just yet. So what we're bothered about is the service. Now we can annotate to say this is a service, and we do that with the at service. That will allow us to give it some sort of starting position to be a service. Yeah. I don't need a repository. I don't need anything specific other than access to this calculation entity. So what I want to do is I'll say public int. So I want to return an int, whole number, add. And I'm going to take in an integer. Let's say A and an integer B. Okay. So now when I take that integer A and B in, I can do something to them. Okay. So I could have just went return A plus B. That's not going to give me what I need from this service. I need to frame this as an actual structure. In fact, we can break this down a little bit more and say, okay, well, I don't care about this A and B. I care about this entity calculation. So I can just take in a calculation calc instead. So I don't have to deal with this A and B directly. Now, remember that calculation has an op A and an op B. And incidentally, we want to add those two numbers together and put them in result. So in essence, I think what we want to actually do, let's write this out first. So we've got what we want to do. So the first thing is I want to take in a calculation entity. Yeah. I want to take the value from op A. Then I want to take the value from op B, add the values from op A and op B together. Store the results. Basically what I want to do in plain sort of steps. These steps could all be stuck together as one step almost. But for now, we have this entity calc. So in theory, we have a few things we can do with it. So if I said calc dot, I've got an equal, I've got a get op B, get op A, get result. I've got a set op B, set result. Now, set result's what I want. I want to be setting the result. So we're going to do that. I want to also get op A. I also want to get op B. Let's just line these up. Okay, so these are three things that I want to do. So let's set these. Let's say int a equals this, int b equals this, and then what I want to do is I want to set the result. So what I want to do is I just want to say, okay, a comma b. So what do I want to do with that? I want to do something with these a and b. So a plus b. Okay, so now we're adding two numbers together and then setting whatever that equals to the result. We could have put c there if we want, or result, or whatever, but for now we've got it sort of in line there, doing what we want it to do. Add values from a and b together and store the result. That's exactly what we do there. Now we want to return an integer. Do we really want to return an integer? Would it not be more interesting as an API to return the actual object to see what we used to add together? And to do that, we can change this to calculation and then just return calc. So now we've added this sort of construct of a service which can take in two values, or rather it takes in a calculation object. It then does a calculation, sets the result, and then returns that overall calculation object back to the caller. So we've now got this construct of a calculation service. We won't do any other stuff in here yet. We've got one method that we can actually call from elsewhere. So now what I'll do is I'm going to make one more thing that I need now. And the thing that I need now is some sort of front end for this. I need some way of the public being able to actually access things and get to these things. And for that, what we have something called controllers. So I'm going to make a controller. So first I'm going to make a new package, call it controllers. And I'm going to make a calculation controller. New Java class. Calculation controller. Now this calculation controller is going to be a REST controller. It's going to be like an API controller. This will be where get, put, post, delete, patch, whatever we want to do. Also, I would like to say, well, what endpoint am I looking at? I'm just going to arbitrarily say my, what should we say? I'm going to say my request mapping is going to be set to calculation. So whenever we go to calculate, well, actually, no, calc, just to save me typing to more stuff. And that needs to be a string. Here we go. So now our endpoint is /calc. So if we went to localhost /calc, this is the controller that deals with the overall area. So now what I can do is I can say, well, hang on, I want to take a post request. I need to put at post and do something with it. So I'm going to say public calculation. And I'm going to kind of mirror what we've just done. So public calculation, add. So this post mapping to add, ideally, I want to say, well, I want to go to the calc /add to do an add. So now I go localhost /calc /add, and that will then use this actual method. And now I want to go, okay, well, how am I going to find out what I want to calculate? Well, the user is going to have to give me some sort of a request body, you know, some sort of data for me to work with. So I can do at request body and say, okay, I want you to give me a calculation. Okay. Now we can actually utilize this service that we've got over here. So I need access to this service. So what I'm going to do here is I'm going to say auto word. This is a Lombok directive. It's something we can have so that I don't have to instantiate things. It does it under the hood for me. So calculation service calc service. Okay, so it's going to automatically instantiate this and give me access to it. So now I can call anything from the calc service within this controller. So now I can just use the add method from the calc service. So I go calc service dot add and pass it the object from the request body. Now I want to return this to the caller because this already returns a calculation. So that's exactly what I want it to return. So return. And you're done. So I'm going to put this all on one line because it's not going to take too much room up here. Let's get that on the same line as well. There we go. So that's my add endpoint. We can do a multiply, subtract, divide, whatever. But for now, we have the ability to add two numbers together. So I'll save that. So we now have this controller that the outside world has access to via localhost /calc/add. And then it can run this, it takes in a request body. It can then return whatever the result is from this calculation service. Now we can't just go on a web browser and do that because we can't do like a post request directly in, well, not just by giving it a web address and stuff. We want a request body here. So we're going to have to use some tooling. I have a thing called Postman, which is great for doing API calls. It can send request bodies, send queries, query parameters, and everything. So we're going to use that. Okay, Postman's loaded. We have this sort of screen here. See this little plus? We can click plus. This will give us an untitled request. So then it's not a get request we want, is it? It's a post request we want. We want to go to http://localhost:/calc/add to do an add request. We need some sort of a body. So we look at this body. I want it in raw. I then want it, instead of text, I want it to be JSON notation. So we're going to JavaScript object notation. So I need to build out this object based upon my entity. So let's go and have a look at the entity again. We've got this entity, calculation entity. It's got op A, op B, and result. We only really need to give op A and op B because the result's going to be rewritten. So that will just automatically become null if we don't give it. So let's go over here, opening curly brace and closing curly brace. Now I need to say, okay, op A, colon, and then what do I want as op A? Let's say 12. That's my first operand. Now, op B, colon, and let's say 2. So we're going to add 12 and 2 together to return 14. So there's our request body. We're sending the request to localhost colon 8080 calc add, and it's a post request. Let's see what happens. It's doing nothing. Why is it doing nothing? Well, the thing here is we haven't started the application. So let's go and do that. You need to press play on this. Run the web application or web API application, and the main method. The good news is it started without error. And we want to see this thing saying started. We want to see that it's in port 8080. Now that we've got that, if I redo this post request, it's not going to say error, it can't get connection to this because it's actually got a server sitting there waiting. Instead, it's going to do this. It's giving me back an object with my op A, with my op B, but also now the result of 14. So it's done the calculation. If I pass it 120 and add 2, it'll be 122. Let's do it again. There we go. So it's able to add two numbers together. How amazing is that? We have an online calculation API that can add two numbers together. Obviously, that's not that useful as it stands. But you can literally elaborate on that and build out more. And it's as simple as almost copy paste. If you think of what we have available here, if I stop that, move that out of the way, how are we going to do this? We've got our calculation service. So if we wanted to add a subtract to this, we could literally grab this, copy it, paste it, refactor it, or we could write it from scratch. We could say public calculation subtract, taking in a calculation, and then do the logic. What is it we want to do? We want to do the same sort of thing as this does here. So I'm going to refactor a little bit of it. I'm just going to copy this. Paste this. This is a synopsis of what we want it to do, but we don't want it to add the numbers together. We want it to subtract the values. The value of B from of A and store the result. That's what we actually want to do, right? So instead of doing it in these int A, int B, blah, blah, we could do all this in line as well. So let's show you that just as a different way of doing it. What we could do is we could say return. But actually first we want to do the actual calculation, don't we? So we'll say calc dot set result. And we'll take in calc dot get op A minus calc dot get op B, and that will give us the updated result. Now we can say return calc. So we don't need all of these things here like this, but we can. I thought I'd show you the broken down version there, and then we'll show you the two-line version here. So I'll save that. Let's start it up and see if the minus works. Well, no, but let's not start it up and see if the minus works. What else do we need? You guys tell me. What else do we need? We've made this. We've made this. We know that this works because we have this part, we have the entities, and we have what else? That's right. Hopefully you kind of spotted it. We need controller. So we need to do another post mapping. For this one, I am going to literally copy paste. I'm going to copy that, paste it down here, change it from add to subtract. And then we're still taking a request body. We don't want to call it add. We want to call it subtract. And we don't want to call calc service add. We want to call calc service subtract. Now we have a subtract endpoint. So if I save that and I go off to the web API application and run it, it should start up and we'll have our new endpoint available to us. I'm hoping you kind of understand enough pretty much to make the next one yourself. I'm still going to go over it, but it's rudimentary and copy paste pretty much from here on out. started web application. So now I'll go back here. First, I'll do the add and make sure that's still working. And there we go, it is. Imagine I want to subtract 2 from 120. Should be what, 118? So instead of doing the add, let's do a subtract. 118. How cool is that? So we've now got a working add and subtract. Let's add all the other ones in. Well, let's add multiply and divide in there. So where are we? We need our calculator service. I'm going to copy paste this a couple of times and refactor. So I don't want it to be subtract at this point. I want this to be multiply. And the only difference is going to be here is a multiplication symbol. And we'll say this one's going to multiply. So we need more of this wording, multiply the values together and return the result instead of add. So let's copy this. Saves me typing a little bit. Not much difference. Do I put multiply too low? Add? So, no, it's because I've got multiple subtracts. That's fine. Right, so now instead of subtracting the result, I'm going to say I'm going to not add, but multiply the values from op A and op B together and store the result, which is exactly what that does. Now, the next one is going to be divide. Let's divide something. Again, divide the value of op B from op A. Well, that doesn't sound right. Divide the value of op A by op B. And store the result. And to do this, we can just do a nice little slash or division symbol. And then we have it. We've got, have I put too many subtracts? What is that mean now? Subtract, multiply, divide. Save it for a moment, might just be a bit of lag. Yeah, I don't think that's relevant. So we've got our thing there. That's doing what I asked it to do. And that's doing what we asked it to do. So now we need to then do the same in the controller. And again, we can just go, okay, I just want to do this thing here, kind of. So we've got multiply and divide. So let's change this out from subtract to multiply. And change the name of it to multiply. And change the actual method that we're calling here to multiply. Remember to do the refactor though, don't just copy paste, you'll break things. Again, instead of subtract, we want divide. Again, here we want divide. And here we want divide. Now we have an add, subtract, multiply, and divide controller. We also have the calculation entity, and we've got this calculation service that does the business logic for these 3 endpoints. Now let's go off and test those. So we know we can do 2 times 120, so let's use the multiply here. What have we got? Oh, sorry, rushing things again. Let's restart the server and recompile because it's still working on the old code. So that stuff didn't exist yet. Always remember to restart your server and recompile your code in Java. Now that that's restarted, let's do another send. 120 times 2 is equal to 240. How cool is that? Let's divide now. 120 divided by 2 should give us a 60, right? And there we go, we've got a 60. Now, these are all whole numbers. What happens when we give like 1 to 1 divided by 2? It floor divides. So that may or may not be what we wanted. At the moment, we're using integers, so we're not expecting to be able to do floating point mathematics here. What we could do is we could make a floating point calculator and a integer-based calculator, or we could do a load of if conditions. But in general, I think this is enough to get you started on the idea of the structure of the actual application. So we have configuration files in there. We've got controllers, which are our front-facing data and endpoints. We have an entity, which is what either has our data models or our business logic models in. We have a service to do business logic operations. Then we've got these repositories, which we haven't really touched on, but we'll touch on in another video. So hopefully you've kind of gained something from this. It's been awesome doing this, and I plan on seeing you all again.